In this video, we will focus on DP-DP coupler in SIEMENS Step 7 and TI portal. As you can see, DP-DP coupler is used to connect DP masters. This is DP master of this PROFIBUS subnet number 1, and this is the DP master for this subnet. These are two independent PROFIBUS networks, and this coupler here is used to make a path or make a way to exchange data between these two masters. As you can see here, this section of the network is related to master number 1. Here you have an independent PROFIBUS DP cabling. You have DP master and several slaves. This is the IS slave, and this is the modular DP slave, and they have the communication with the master. In this segment of the network, you need to have an independent power supply. The power supply is independent of this part of the network. All the power required for the module in this segment is provided by this source. If something wrong happens with the power supply here, or something wrong happened with the cable, and you have a problem in this network, you will have an error, PROFIBUS error here, while the other network here is trouble-free, and it can communicate without any error, because the power supply in this master DP subnet is independent of the adjacent system. For here we need a green square with green color inside. So the power supply is independent and the networks are independent, and you have a path of data communication between these two masters. This is the ultimate role of the DP-DP coupler. The other point here is this PROFIBUS network should be in form of copper cable, or if it's a huge PROFIBUS network, and it may contain fiber optic connections. Here you need to use for connection to this DP coupler here, you need to have the copper cable, and here also the copper cable. the next slide. In this slide, you can see the Profibus network number 1 and Profibus network number 2. The speed in these two subnet can be different, and to send data from master 1 to master 2, DP master 1, you will send data as output to DP coupler, and this slave, DP coupler, is a slave in this network, and it's another slave for the next network. The output data is provided here in the buffer, and it will be provided as input signal for this master, and from master in system number 2, the second master provide the data as output, and they're converted or buffered in the input for the master number 1. So DP coupler is two slaves connected in two different independent network, and they are galvanic isolated. In this slide, you will see that this communication between these two CPUs is configured within the S7. 4 bytes of data are transferred from this CPU to the buffer in the DP coupler, and it's provided as input to the master in the network 1, and 4 bytes of output is provided as output from CPU 1 to DP coupler, and it also provides the 4 byte of output to the master CPU here. In this slide, you see we have master number 1 and DP coupler. The first half of DP coupler is considered to be the slave interface for master number 1. The output in master 1 is written to a buffer in DP coupler, then it's transferred, and it will be an input area for master number 2. And master number 2 will provide data as output in this side of DP coupler. It's a slave for this master. Data internally transferred to this area as an input area for master number 2. This connection is electrically or galvanic isolated. Possibly it's optically transmitted between these areas, and any fault in this network cannot damage communication in this Profibus network. And an actual step 7 configuration, and you have the layout of the DP coupler. In this area, you need to connect the power supplies. These two are for the connections for Profibus number 1, and these are for Profibus number 2. This is the port for Profibus DP1, and this is the port for Profibus DP2. And here we have indications for the communication. System failure 1, system failure 2, bus fault 1, bus fault 2, and 2 on signals. These are indications will be explained in the other videos, and we have 2 dip switches to determine Profibus network address for the first and for the second connection. This is the actual connection. 24 volt DC for the first Profibus DP. This is the connection for Profibus DP number 1, and this is the connection, DC connection for Profibus number 2, network 2, and this is the actual network connection. Well, the next step will be connecting the 2 master systems by using a DP coupler in step 7, and write a simple program to show you how to program program a data exchange between 2 masters in a 2 different networks, DP networks, by using a DP coupler. Now it's the time to connect 2 DP master systems in schematic step 7. The next step is to create an S7-300 station, and the name is changed to Master 1. We create a hardware related to S7-300. We need the rack, and then a power supply, CPU. We need to have Profibus. We need to add a CPU with the Profibus port. Profibus 1. Profibus 1. And the first station is completely configured. We have here Profibus number 1 and master number 1. We need to make a copy of the subnet, change the name to Profibus number 2, and we need to copy the S7-300 station and rename it to master number 2. In master number 2, we need to open the hardware configuration and double click on DP, select Profibus 2, finished. So we have 2 stations. In NetPro we can see the hardware configuration and network assignment. Master 1 is connected over Profibus to Profibus 1, and Master 2 is connected to Profibus number 2. Now we will move to the hardware configuration, and first we go to Master 1, and we need to add a DP slave from additional field devices, gateway, PROFIBUS DP coupler version, release 2. We add this on the PROFIBUS network line on PROFIBUS 1. You can change the address as you wish. You can consider this as 6, 7, 8, anything you want, any free PROFIBUS DP number. I select 6 here. Here I can add 32 byte of outputs because I want to send data from master 1. 32 of outputs and 32 bytes of inputs. You can change these addresses as you wish. So the first module is an output. In the master number 2, we need to read. We need to have the input module first and the output modules. We open the master 2 hardware configuration. Same. Select any free PROFIBUS DP address in data station. I select 9. Okay, we had in master 1 first we had output. Now here we need to have input to receive 32 bytes of input and 32 bytes of outputs. If you make some mistakes here, you may encounter a trouble. To be sure, first let me save and compile. To be sure, we need to arrange these windows vertically. Again, windows arrange vertically. And okay, we have in master 1 we have 32 bytes of output, and we receive them by 32 bytes of input in master 2. At the same time, we have 32 bytes of output in master 2, and we receive them as input. Let's send 1 byte from master 1 and receive that in master 2. To send, we need to write something in Q byte 0. In master 1, we go to the OB1. Load byte. Transfer Q byte 0. The Q byte 0 is, we are in master number 1. The Q byte 0 is moved from here to IB0 in master 2. Then we go to master 2 and read the data in IB0 and transfer it, load IB0, and transfer it to MB, for example, 100. If the connection is established perfectly, we will have arrange vertically. Again, arrange vertically. Thus, if everything is done correctly, data in master 1, all 0 is transferred to Q byte 0, and the same data will be received in master in two different master CPUs. I hope you find something new here, and thank you for watching.